Hello everyone, dear viewers. In this video, we'll continue from where we left off and finish building the entire control system. Previously, we initialized the control system, but this control system, the control rig, hasn't actually been connected to the character skeleton yet. So in this episode, we'll cover how to set up control chains. Let's first open Kinetich's control rig. Once inside, you can see this graph. It's completely empty. We need to create some IK chains here to make the bonds move. Of course, in the actual production workflow, we won't build everything manually from scratch. Instead, we just copy an existing control rig. For example, we can copy Rymu's, because Rymu also plays the piano. Go find Hakure Rymu's control rig. And then just take all of this, copy it directly, and paste it over. But before doing that, I need to explain to you first which blueprint nodes are used here and what their functions are. In the previous video about character skeleton preprocessing, we introduced there are mainly a few IK control chains on the character. First, both arms, then each finger, next, both feet, and finally, the character's upper body. Those are the IK control chains. So, what we'll mainly use are various IK nodes, along with an aim constraint, for controlling the direction the head faces. In Unreal, the built-in IK nodes are as follows. One is CCDIK. Then there's Basic IK, and also Basic Fabric. From the user's perspective, there's no essential difference between them. And there's also one called IK bond. Let's look at the first two types, CCDIK and Fabric. They both accept an item array as a parameter. In other words, we need to select a bond chain. For example, if we want to control this arm, then we find it. Let me find where the hand is. Let's say we want to control the right hand. When selecting, you must start from the root bone and go down level by level. However, if you want to check if you've selected correctly, the best way is to do it in reverse. You should first look at the end bone you want to control, which is the right hand. Then go up one level, right here. Then go up another level, to here. You don't need to worry about sibling bones in between. They don't affect the IK. If you select them, it'll only cause calculation errors. If in Blender, you just select the end bone, then set the IK chain length, it automatically traces back to the root bone. But in Unreal, you have to specify it manually. And when selecting, you must start from the root bone, then go down level by level. It's easy to make mistakes in between. Now we can drag out the bond chain. To generate an item array, it can be connected to the pin of the IK node. Then the IK node can control this chain. But the latter two IK nodes are different. They require you to select each individual bond. Still using the right arm as an example, it becomes bond A is this one. The second bond, I selected wrong. Bond A is here. Bond B is here. And bond C is here. Why didn't it select? Clicked, but it didn't select. These nodes don't accept item array. You can only select bonds manually. It's the same for Basic IK. It only supports manual selection. So here's the problem. If you're just controlling an arm, it consists of 3 bounds, then any IK node would work. But what if I want to control finger bounds? That's where the trouble starts. For example, let's look at the thumb. It has 4 bounds. 4 bounds means the latter 2 nodes have to be skipped. Can't use them. You can only choose from the first 2 nodes that accept item array. You can add a new item. Keep adding, no problem. But the first 2 nodes also have limitations. What are their limitations? They only have 1 edge effector. What are they missing? They're missing a pole vector. Also known as the pole vector target. While the latter 2 nodes both have a pole target. Pole target can control the bending direction of the bound chain. So here's the dilemma. Not a single node can do both. Having item array support for multi-bound chains, and having a pole target to control bending direction. So the final conclusion is that none of these 4 built-in nodes can be used. This is also why I had to write my own IK node. This IK node is called the arc distribution IK node, and it comes with a pole target. It's modified based on AC/CD IK node. It supports both features mentioned earlier. I'll use the thumb as an example. First, drag out the thumb item array. We connect it here. Next, we need to choose which control to use to manipulate it. Remember what we said earlier. The thumb is actually the first finger of the right hand. It's arc. Let's drag it out. Connect its transform to it. We control the thumb's orientation with pole 5. Let's drag that out too. Then we only need its position. Drag it into the pole target. Now let's connect it and see the result. After connecting, the finger is deformed. This result is wrong. What's the reason for the wrong result? Let's take a look. Let's disconnect the wire first. The bones we selected were exported from Blender. Their primary axis direction is the y-axis. The secondary axis direction is the blue z-axis, the red x-axis. So the primary axis must be set to y. But in Unreal, the default primary axis is x, so we need to change it. Change it to the y-axis. For the secondary axis, we want it to bend toward the z-axis, so here, we need to change it to the z-axis. After the changes, let's connect it again and check. Still wrong. Found that the finger completely retracted. This indicates that although the primary axis is y, the sign is reversed. It should be e. Alright, now it's showing. But the finger orientation is off. This is where we need to use pole target to adjust the orientation. We find pole 5, right here. Let's move it out. Like this, it's very convenient to control the finger orientation. This is how this IK node is typically used. For fingers and arms, we just set them up like this. At the time of video release, the latest finger control chain was implemented on Farina in the project file, adding an extra ext control to achieve more natural finger effects. Next, I'll talk about this node and how it's used on the upper spine. Let's take a look. It has 2 Boolean parameters. The first is negative pole. What does it mean? For convenience, let me first fix this pole target in place. Otherwise it resets every time I compile. After we check negative pole, you can see, with the pole target position unchanged, the entire finger bending direction is reversed, pointing to the other side. Some of you might ask, why not just change the sign of the z value? That is, change the secondary axis direction to -1. We don't check negative pole. Instead, what happens if we change the secondary axis sign to -1? The bending direction of the bone chain hasn't changed. It's just that every bone in the finger has flipped around, or reversed. So the two effects are different. So this parameter, when should it actually be used? We need to apply it to the upper spine. Now let's create an echinoid. Change it to target the upper body. Let's first find the upper body bone chain. From here, here, here. Then up to the head, for bones total. Let's delete this. Drag out this item array. Then connect it up. The end effector for the upper body is the head. So we need to use head control to replace it. And the upper body's pole vector is essentially the character's facing direction. So we replace it with look at. Okay, replacement done. Let's connect it and take a look first. After connecting, you can see the character's upper body is indeed bending toward the pole vector direction. But the effect of this bending looks a bit like pigeon chest. Normally, humans shouldn't bend forward like this. Even when humans bow their heads, the spine generally bends backward. It becomes hunchback, not pigeon chest. So in this case, we need to check negative pole to change it from pigeon chest to hunched back. Next, there's another Boolean parameter called useProgressiveTwist. What does that mean? Let's move look at to demonstrate. When moving look at, you'll notice, wait a moment, the rotation of the head. I also need to add an aim constraint. Otherwise it looks a bit odd, because the head is now controlled by the end effector head control. Both position and orientation. So we need to make head control face toward look at. That way the head will look toward look at. We need to add an aim constraint node. But I'm used to just searching for look at. Directly search for look at, and it'll appear. Now we want head control to face look at. Show head control is the child. In the child field, we select head control. And the target, look at, is the parent. In the parent field as the parent. Let's select it. After selecting, we're not sure if this orientation is correct. Let's connect it and see the effect first. Then let's move it. Okay, this confirms the orientation is correct. If it's not correct, you mainly need to change this aim axis. As for this side, basically no need to change, because the default up direction is usually z-axis up. Now, through this look at, we can change the character's facing direction, the rotation of the upper body bones, but there's something unnatural about it. From the waist to the chest to the neck, every bone rotates at the same angle. But in reality, humans don't rotate like that. Normally, the neck should rotate the most, the chest rotates less, the waist rotates the least. It should actually be a progressive rotation, rather than a uniform rotation like this. So at this point, we should enable use progressive twist. Check it. After checking it won't have every bone rotating the same amount. This makes the range of motion look a bit more natural. Now let's also look at the tool. If we lower it, the character will tend to hunch over a bit. But we don't want it too hunched. That would just look ugly. Generally, you want to keep it at a reasonable position. So this is why the custom IK has these parameters. They apply to different situations. Also, there's the precision value. The default is 1 meter. But 1 meter is honestly a bit too large. You can change it to 0.1 based on the actual situation. You see, when it was 1, the character looked like this. I change it to 0.1, the end bone gets closer to the end control. It becomes more accurate. Changing it to 0.01 doesn't make much difference. So 0.1 is sufficient. Okay, so that's the IK node we'll be using. And the explanation of the aim constraint. In the actual production workflow, we don't do it this way. Creating them all manually like this would be exhausting. In our actual production workflow, we just copy an existing control rig. Then we paste it. Okay, it's over. Drag this out. After pasting, without worrying about the details, we'll just connect everything first and fix any bugs when we find them. Ah, indeed bugs appeared. Let's go through them one by one from top to bottom. First, what's the first one? The first is interpolating between the left-hand control and the right-hand control. With a parameter of 0.5, then applied to mid-hand. This essentially syncs mid-hand in real time, ensuring it stays right in the middle of both hands. This one is fine. Then let's look at this aim constraint. This aim constraint probably has an issue. At the time, we defaulted it to face the x-axis. I'll change it back to the default value. And now it's working fine. Now what is this IK to bone? Okay, this IK to bone is for the character's upper body bones. Because Rymu's upper body actually only has 3 segments. Still using the old IK node from back then. Not using the new node I just introduced. So let's change it. We'll change it to the latest 4-bone IK chain. Then we use lookat and head control to control the head. The axis needs to be changed. This should be the y-axis. The secondary axis should be z-axis. Check both items here. Wrong. This should be y, not y. Now, that's correct. Now let's deal with the sections below. This is the left arm. We can see the twist has some issues. But twist isn't handled by IK. There are nodes below that handle twist. We'll check this part later. Let's first check if its IK is working properly. Check the left hand. The left hand's HP position might need adjusting. Move the HP position back a bit. Move it here. Then set the current position as the default value. The twist bounds have issues. Let's first disconnect the twist bound parts. These are the foot bounds. I haven't added foot controls for Kinech yet. So I'll delete this part for now, since Raimu was sitting and playing the piano. So I manually created foot controls back then. There is a bit of an issue here. Let's take a look. This is because of a bone hierarchy issue. The bone hierarchies on both sides are different. Kinech's first level should use this one. The second level should use this one. After changing the right hand, now it's working fine. The right hand's HP also needs adjusting. Like this, it's working fine. Let's also change the left hand while we're at it. The hierarchy of each bone isn't necessarily the same, so you still have to fix these things yourself. Okay, this looks normal now. Now let's look at the fingers. The fingers will definitely be quite different, because the naming conventions for the finger bones are different. Mainly the naming of the end bones is different. We just need to change the end bones for this. Oh, let me see. This is the fourth finger of the left hand, which is the thumb. The direction is off. The pole target orientation is wrong. We need to check if it's the pole that's the problem, or if it's the axis. Let me move the fourth finger's pole vector up first. So it was in its position. That means there's no problem here. The secondary axis is fine. It's just the pole itself that's the issue. Then we just need to change the pole's default value. Okay. There shouldn't be any major issues after this. I'll go through and fix them one by one. The basic principles are all the same. So I'll fast forward through this part. So, up to this point, the control rig blueprint is now fully completed. If you have any other needs, such as adding foot controls or anything else, you can go ahead and add them. In the actual project file, for the arm twist bones, a copy rotation offset single axis node can be used to replicate the rotational changes along the y-axis of the hand bone, with the influence gradually decreasing from the hand toward the arm. The control chains described above can be examined directly in the project file. So this episode ends here. Thank you for watching. See you in the next episode.